Hey everybody, so I'm back out in the pinyon juniper woodland biome. I'm not in Bangs Canyon this time. I'm in a different canyon over by Palisade called Big Wash Canyon. It's off of Highway 65 as you drive up onto the Grand Mesa, and it's the same habitat, same biome as Bangs Canyon. However, we're going to focus on something a little bit different today. We're going to focus on organismal interactions, how different organisms interact with one another. Now, I gave you a couple of examples of this in our first video with mistletoe and how it's a parasite on the juniper tree. It feeds off of the juniper tree and it hurts the juniper tree. Parasitism is an example of an organismal interaction. The mistletoe is interacting with the juniper. I also gave you another example when we were in our other video of lichen, and I said how lichen is a symbiotic relationship. Symbiosis is another type of organismal interaction. This is where both organisms benefit. So we're going to take a walk through this canyon and we're going to see if we can find some more organismal relationships. So let's begin with our first type of interaction, mutualism. Mutualism is where both organisms are going to benefit from the relationship. So there are several examples that we can find here in Western Colorado of mutualism. One of them is lichen. Lichen is a mutualistic relationship between a fungus and an algae. They are helping one another. Another example would be clownfish and a sea anemone. The sea anemone provides protection for the clownfish, and the clownfish is going to provide food for the sea anemone. You might ask, what kind of food? Well, he poops, and that poop can become food for the sea anemone. So this is a mutualistic relationship. These relationships aren't perfect, but they get the job done. So here's a perfect example of mutualism. On this rock here, we have a whole bunch of different lichen. We have several different species. You can see we have kind of this really pretty orange species. We kind of have a flaky green species and a black species of lichen. This is a mutualistic relationship where an algae and a fungus are living together and helping each other out. So a good example of mutualism would be pollination. Pollination is when an insect or other organism pollinates a flower. It's benefiting both organisms. Now, most of you are probably familiar with predation. Predation is when one organism eats another one, so it's benefiting one organism and harming another one. A good example would be you. You are a predator. Anytime you eat a cow with steak, or if you eat a salad, you are a predator. It's not doing that lettuce any good for you eating it. So it's a positive thing for one organism and a negative thing for the other. So predation, you know, we can think of it as being something like a lion eating a zebra, but you have to think it's also something like a caterpillar eating a leaf, or a wasp eating a caterpillar. Oh, there we go. All right, so I found an example of a predator. Now we don't see it, but we can see the effects of it. Now what we're going to look at is an antlion larval trap. Antlions are insects. They belong to an order of insects called Neuroptera, and their larvae are very ferocious predators. And what they do is they build a trap. That's why they're called antlions. And they build a trap that's a cone. What happens is the ant will move along and then fall into the cone. The antlion larva is at the base of the cone, and he grabs that ant and he eats it. Antlion adults look a lot like dragonflies, but they're not dragonflies. They are in their own insect order, Neuroptera. Science. So I'm back up here in the pinyon juniper woodland to revisit our mistletoe. Remember, mistletoe is a parasite. So this is a parasite that is living on the juniper tree. So this is an example of parasitism. Now, to take this a step further, there is one of my favorite butterflies called the great purple hair streak. Its caterpillars eat the mistletoe. So that is predation. So we have a multitude of different things going on at the same time. We can have the mistletoe eating the juniper as a parasite, but then we can have the great purple hair streak caterpillars eating the mistletoe. So this is a little more complex than you would think when you deal with these organismal relationships. So with parasitism, remember that one organism will be benefiting off of another organism, and that second organism will be harmed. So it's a positive and negative relationship. Now, usually with a parasite, the organism benefiting is going to be a simpler, less complex organism that's attacking the more complex organism. A really good example of this would be a tapeworm invading an animal's intestines. The tapeworm is benefiting, but the animal that's being infected is being harmed. Another example would be these flies that are parasitizing these dogs in Africa. What happens is these flies lay eggs in the dirt, then the dogs lay down in the dirt and get infected with this fly parasite. The fly larvae then burrow into the dog's skin and cause a parasitic relationship. So parasites are similar to predation, except it's usually the weaker organism that's benefiting off the stronger or more complex organism. The next type of relationship is commensalism. Commensalism is when one organism benefits and the other organism is not harmed nor helped by the interaction. So commensalism is a little tricky, and it can be confused with mutualism. If the organism is benefiting, then it shifts to mutualism. But if the organism is not benefiting and the other one is, then it's what we call commensalism. Commensalism could be as simple as a bird sitting on the back of an alligator. If the bird is benefiting but the alligator has no real benefit or detriment, then that is a good example of commensalism. Competition is where two organisms are going to be competing against each other. Now this could be something like bull elk competing over a female, or something more simpler like two plants competing for space. You have these two trees. You've got this fir tree next to this juniper tree. They could be competing for space, for light, for soil, for water resources. If they get much bigger, they will be competing with one another. Now, competition results in a negative relationship for both individuals. So in this case, both trees could be negatively impacted by their relationship. Another type of interaction is called Amensalism. Amensalism is where we have two organisms where one has no effect at all and the other one is being harmed. Now, Amensalism is performed by humans quite a bit. We harm other organisms without doing any damage to ourselves. We are the king species of Amensalism. Now, by far the most common relationship is actually a lack of relationship. We call this neutralism. This is when two organisms have no interaction at all. It's actually not even a relationship, but it's on our chart right smack in the middle, and we call it neutralism. Neither organism are affected by the other one. So when we look around our environment here, we're going to see lots of neutralism. Organisms that aren't even interacting with one another. So in this case, you can see we've got neutralism all over the place. Those junipers are not interacting with the grass. The grass is not interacting with the bugs flying around. Those bugs flying around are not interacting with the trees. The willows are not interacting with the cactus up on the side of the hill. This is called neutralism. I am part of this environment, so I am not affecting the pinyon up on the side of the hill. Now, if I go and chop it down, then I have another relationship. It's also important to understand that these organismal relationships are not set in stone. They can fluctuate back and forth. So for example, you might have a mutualistic relationship with bacteria in your large intestine. You are benefiting that bacteria. That bacteria is benefiting you. However, if that bacteria gets into a place where it shouldn't be, like in your body cavity, the relationship changes from being mutualistic, benefit, to being parasitic, where that bacteria is actually harming you. So these interactions are going to change all the time, and we can move from box to box at any given moment, depending on the relationship circumstance.